Hello, my name is Reza, and I'm a graduate student, and I had the electric vehicle design course. As it was mentioned before,
my name is Erik Johansen. I am in a team with Ehsan Qiyassi, Reza Tavakoli, and Jeremy Thorpe. We are in the electric vehicle design course. We built an electric bike. It works by having a boost converter that boosts the battery voltage from 24 volts to 50, and then an three-phase inverter that puts it in three phases for the motor to use. So on our bike here, we have our battery in here, has a nominal voltage of 24 volts as I mentioned previously. The power comes through this cord, through these orange and blue wires here, goes into the boost converter, which is this section, goes through the inverter here, and then comes out through these three phases to the motor here on the front tire.
for the output of the battery is about 24 volts and is changing. We need a boost converter to have 50 volt at the output, 50 volt for the inverter. To have always a constant 50 volt, we need a controller. For the controller of the boost, we used a dual loop controller which maintains a 50 volt at the output of the boost. The structure of this dual loop is that it samples the voltage of the V-bus. It compares the value with the reference value, which is 50 volt. Given that to a PI controller, I have a reference value for my current. Having that reference current, I sense the current of the inductor, again compare it, I have my error. I give that error to another PI controller. It gives me a reference value for duty cycle. I give that duty cycle to a pulse width modulator and to a gate driver that produce the gate signals for my two switches here. These are my two switches for the boost controller, boost converter, and these two are my PWM generator and gate driver, which generate the right signals for the boost. The controlling signals and the operation of the controlling for the duty cycle is coming from these controlling part. I have this inverter that needs a constant voltage at DC bus, which gives the proper output voltages for our motor. Here you see the structure of the inverter, which has 3 legs for 3 phases of the BLDC motor and 6 switches. The BLDC motor gives us, it has an output of 3 Hall sensors, which gives the position of the rotor, and through the actual values of the 3-phase currents and a hysteresis controller, we have the right switching pattern for our 6 switches. Go.